Hello and welcome to another tutorial on dev.java website, and we are looking at Java language basics. So let's start with number one, creating variables and naming them. I'm gonna expand this. So the current tutorial is creating variables and naming them. Variables, as you learned in the previous section when we look at getting started with Java, an object stores its state in fields, right? And we said that everything in Java is objects, right? Classes. And then a class can have fields and methods. So you basically group some data and actions that you perform on those data in the format of a class, right? So the data are stored in variables. Could be array, could be a collection like a list, or could be just plain primitive data like integers. So we call these fields. In Java, in C++, we call them member variables. So you know that in Java we cannot have for example, define a variable outside a class. We cannot say double A equals 2, where this definition is outside the scope of a class. In C++, for example, we can do that, and these are called the global variables, because if you define something outside the scope of a class in C++, it's in the global scope, whereas in Java there is no global scope. Everything has to be within the scope of a class. That's why everything in Java, every data is somehow related to the fields. Could be a static field or non-static. And again, I mentioned before, if you look at the Eclipse outline, anything that has this dot white, or it's a plus sign, it's a white white symbol inside the variable. It means it's a field, it's not a method. Whereas this one, it's a solid rectangle, right? So it doesn't have any white dot in it. It means this is a method. Now the color and the symbol of the that is used for the variables or fields, it depends on the type of access modifiers. Every field, everything is within a scope of a class, and within a scope of a class you want to enforce encapsulation, right? So enforcing encapsulation means you want to restrict the user's access to the amount of data or methods that are available in this in the implementation of this class. So encapsulation is about access restrictions, and Java provides beautifully ways to explicitly tell what is the access restriction. We can have a public access modifier. So these are called access modifiers, and these could be public, protected, or private, or none, or basically empty, nothing. If you don't provide any access modifier, it means it's a package level access modifier. Now in C++, package level access modifier means other classes are friendly to your class in the same package, right? All the classes are friend to each other. So in C++, we have the explicit keyword friend, and you can tell a class that, hey, other classes or other methods are friends, and they can have access to the internals. For example, they can have access to this field. Whereas in Java, I mean, it's not, they didn't implement this friend type of thing because it just makes things complicated, and Java is all about simplicity. So instead, they provided the idea that if there is no access modifier used on a method or field, it means this method or field is accessible to all other classes in the same package. And the concept of package is pretty much the idea that you want to group classes that are related to each other. They strongly interact with each other inside the same package, right? And then if you want the user outside this package to have access to something, you make them public or protected, for example. So always, so the best practice obviously is to always go private, and for methods and fields. So always start with the strong encapsulation and gradually restrict or relax this kind of restrictions, right? So the best practice so everything has to be private unless absolutely necessary. One thing to note is that although these provide very nice encapsulations and Java Reflection API can defeat this kind of restrictions, right? So if somebody wants to defeat this, they can access these using reflections. And at the moment, there is not a strong safety nets in reflection. So so you have to always be careful and about Java Reflection API and what's possible with that to for example get access to this. In a Java Reflection API, the easiest thing to do, you get a field object that describes the field of this class, and then you just set accessible to true. That's it. And then now it can be accessed. If you don't set accessible to true, then the JVM throws an exception if the user wants to get direct access to this or directly modify, right? So variables, these are some variables. We're defining integers. Int is in Java, int is 32-bit, and that's the strong guarantee that Java provides. So int on different platforms, CPUs, operating system, might not be actually 32-bit if you use C or C++, but Java provides this strong guarantee that whenever you use int in Java, inside the JVM, it has to be 32-bit. That's the strong guarantee. So what is an object? Discussion introduce you to fields, but you probably have still a few questions, such as what are the rules and conventions for naming a field? And we said that in Java we follow the best practice of camel case. Camel casing means if you have a field that has more than one syllabus, so more than one syllabus, you want to go with camel case notation, which means let's say I want to have a variable the taxpayer, for example, identifier, right? So the way you define it, let's say you say double tax payer identifier, for example, right? So camel case means each syllabus is capitalized, has the first letter is capitalized, except for the first syllabus, right? Tax, or the first word. Now there are other type of notations. For example, a snake case is very common in Python and C++. A snake case is everything is small letters, but you separate them with underscore. So you define this as double tax underscore payer underscore identifier. So but a snake case is not recommended for Java. Camel case is the recommendation for Java. The compiler JavaC doesn't put any restrictions, so you can use a snake case or double camel case or whatever you want. There is really no hard restriction. For example, I just converted this to for example a snake case notation, but it's not best practice. So if you want to make something public, then definitely follow the best practice and then make it a camel case notation. Now if you are familiar with the Java native interface, or you have followed my tutorials on Java native interface, you know that when you try to create a header file for this kind of basically underscores are problematic in the signature of the native method that binds to a Java method, right? And they had to replace underscores with something else, and they replaced it with _1, for example. So underscores is definitely not a good idea to use in Java, not just because of the readability, and not just because it doesn't follow the best practice or the recommendation practice for naming conventions, but it also may create some complications when you use Java native interface, this kind of stuff. So let's continue. What are the rules and conventions for naming a field? Besides int, which declares the type, any variable in Java must have a type. The compiler, before assigning any value to it, the compiler has to know what the size in bits or bytes of that variable is. Anything has to have a type, and this is the concept of a statically typed language. Besides int, what other data types are there? Do fields have to be initialized when they are declared? No, any field inside the class will be initialized by the JVM. So right now, you might assume that this field X, for example, when the class is loaded, this may hold garbage value, but that's not the case, because when the JVM loads this class in the memory for the first time, this field will be initialized to 0. So the JVM looks at the type of this variable and then initialize it accordingly. And then we'll explore the answers to such questions in this section. But before we do, there are a few technical distinctions you must first become aware of. In the Java programming language, the terms field and variable are both used. This is a common source of confusion among new developers, since both often seem to refer to the same thing. And we say that field means variables that are global variables in a class, and we can also have the concept of local variables, right? But fields are basically global variables in a class, or they call class variables. And in C++ we say member variables, right? In Java we cannot have any variable outside the scope of a class. In other programming languages like C++, Python, we can. That's why in C++ they call them member variables or member fields. When you say member, it means it belongs to a class. But because in Java everything belongs to classes, there is no point of using member variable or member field. We just say field, right? This is a common source of confusion among new developers, since both often seem to refer to the same thing. So what is the difference? The Java programming language defines the following kinds of variables: instance variables or non-static fields. Again, I mean, if you're familiar with C++, this is called the member variable or member non-static member variable or non-static member fields. But in Java language we don't use the word member, because everything belongs to a class, right? So instance variables or non-static fields, technically speaking, objects store their individual states in a non-static fields. So a state of an object is the values that is basically the data that is an instance of the class holds. So a state of a class or an object. So we say, so a class is an abstract or a blueprint, right? So a class doesn't have a state. An instance of that class or an object that belongs to that class type can hold a state. And a state is just relates to the values or the data that object holds, right? So let's for this class, for example, let's create a set x value double x, and we say this dot x equals x. So we have a setter and getter, so it has to be void, right? A setter doesn't return anything. And let's create a main method. So main doesn't belong to the state of the class. Main is just entry point to the application, right? So what we want to do, we want to change the state or create an object of this type. So var class1 is a new my class 2, all right? And then so this cls1 or class1, or let's call this obj1, this is an object or an instance of this class, right? So we create an instance, and we can create another instance, right? So var object2, and these are two different instances, and each one can hold its own state. So here we say that this object holds 1.1 for x, the other one can hold another value like -10. Object 2 set x -10, right? So we have instances or objects that belong to the same class, but they have different states because the data that they are holding, the data that these instances are holding, are different. So a state of an object means data held by that object. When we say object, means it's an instance or a concrete instance of a blueprint of a class. So non-static fields, that is fields declared without the static keyword. Non-static fields are also known as instance variables because their values are unique to each instance of a class, to each object. An object is an instance of a class. A class is a blueprint for creating or constructing objects by calling the constructor or other factory methods if the constructor is not directly accessible. In other words, the current speed of one bicycle, current speed here of one bicycle is independent from the current speed of another. Basically, we have an object, let's say bicycle, that holds these data, these fields, these member variables, and these are non-static, which means different bicycles, different instances of the bicycle class can have different values. They can hold different data. Class variables or static fields. Static means something that doesn't change, right? Static means, what this means is that different different objects of the same class or different instances, they all share the same value for that field, right? If one of them changes this static field, the others immediately see that change. So a class variable is any field declared with a static modifier. This tells the compiler that there's exactly one copy of this variable in existence, regardless of how many times the class has been instantiated. A field defining the number of gears for a particular kind of bicycle could be marked as static, since conceptually the same number of gears will apply to all instances, right? So if it makes sense for some data to be shared among all instances of a class, then you have to make it static. That's the meaning of a static. Similarly, for a method, you can have a static method, which means that acts on class variables or static fields, and then all the instances of the same class, they have the same behavior in that static method, right? So you cannot override a static method that doesn't mean anything. The code static in gear 6, so this variable is integer, but it's static, which means it belongs to the class. It doesn't belong to a particular instance of that class. Would create such a static field. Additionally, the keyword final could be added to indicate that the number of gears will never change. So final is it's kind of have a funny business in Java. I will discuss the final keyword in the next lecture, but there are concepts such as Const Correctness or Const, which were never truly materials in Java just because of the limitations that exist. They try to add this final feature, final keyword, but it doesn't really make something really const correct, right? So const correctness doesn't really apply in its like hard sense, in its strict sense. But final can get us close to the concept of const correctness. So back to this class, let's say now we define a static field, a static double y. Let's initialize it with 1.1, or let's say 2, right? What this means is that every instance of this class that I create, they all share the same value for y. And if one of those instances change this y, the other instances immediately see it. So let's try that. So let's say obj1, and we can directly access y here because we are in the scope of the same class, right? And let's set it to 5. Okay. And then I'm gonna now let's see what happens when we create obj2. We can say obj2.y. Now this y should return 5 because we are changing and yes, it returns 5. Now you see Eclipse gives us a warning, and the warning is that why are you accessing why are you working with a static field using a reference to an instance of a class? You have to use, or basically it's recommended that when you are dealing with static fields and methods, don't associate them with a reference to an object of that class. Just associate them with directly to the name of the class. So it says it should be accessed in a static way, but this is not a compilation error, it's just a warning. What this means is that instead of associating this y with this particular instance, because it could be misleading, because now we're accessing y through another instance and these y's are the same, use the class name so that this y is associated with the class itself, not with a particular object of that class. Same here, right? So we are now, it makes the code more readable, and that's why it's not a compilation error. It's a warning saying that, all right, if you associated y with the reference obj1, then that might confusion when somebody reads your code, right? But this line doesn't make any confusion. This y is directly associated with the class, which means this is definitely a static variable. And this still works fine. We are using this, changing the value of a static field y using the class name, and then later on when we look at the value, it's already changed. So I hope you understand this. Now have a good understanding of what's the static field, what's the non-static field. You have some idea about access modifiers, and what is a class, what is the instance of a class, what is an object of some particular class type, etc. So I hope you enjoyed this. Please stay tuned, and I'll see you in the next one.